Have you ever questioned what the universe is made up of, right down to its smallest, most fundamental level? Traditionally, we've understood matter to be composed of atoms. These atoms, in turn, are made up of protons, neutrons, and electrons, the basic building blocks of our reality. But as we delve deeper, we encounter a new realm of quantum particles, quarks and leptons. They form the basis of the standard model of particle physics, a theory that has enabled us to predict and understand the behavior of these subatomic particles with astonishing accuracy. Yet the standard model isn't without its shortcomings. Despite its successes, it fails to reconcile with the theory of general relativity, one of the pillars of modern physics. It leaves us grappling with fundamental questions about the nature of space, time, and the universe itself. But what if there was a theory that could potentially unify all of physics? Enter string theory. At its core, string theory suggests a radically different view of the universe. It's a theory that has been weaving its way through the fabric of physics for over 5 decades, and yet it remains as elusive as it is fascinating. String theory proposes a mind-bending idea that the fundamental particles we've known, like electrons, quarks, and photons, are not point-like as we've always imagined. Instead, they are one-dimensional objects, or strings. Picture this. Instead of imagining these particles as tiny dots, we should see them as incredibly tiny strings, vibrating like the strings on a guitar or violin. This vibrational nature of strings is what makes string theory truly compelling. Each string can vibrate at different frequencies, and each frequency corresponds to a different particle. It's much like a stringed instrument. You pluck a string, it vibrates, and it produces a note. Similarly, these strings vibrate and produce particles with different properties. The frequency of the vibration determines the mass and charge of the resulting particle. So, an electron, a quark, a photon, they are all just different notes on a cosmic string. But that's not all. String theory also introduces the idea of extra dimensions. Up until now, we've been comfortable with our 3 spatial dimensions and 1 time dimension. However, string theory suggests that there could be more, up to 10 dimensions in fact. These extra dimensions are hidden from our perception, curled up in such a way that they are almost impossible to detect. It's a concept that's hard to wrap our heads around, but it's a cornerstone of this theory. So, in string theory, everything in the universe, from the smallest particle to the largest galaxy, is composed of vibrating strings. It's a symphony of cosmic proportions, an orchestra of strings playing the music of the universe, and we are all part of it, composed of these vibrating strings, participating in this grand cosmic concert. Now you might be wondering, what does all this mean for our understanding of the universe? Well, let's dive into the potential implications of string theory. First off, one of the most intriguing possibilities that string theory proposes is the existence of a multiverse. Yes, you heard it right, a multiverse. Rather than a lone universe, we might be part of an expansive multiverse, housing a vast array of universes, each with potentially different physical laws. This idea, while still speculative, could open up a whole new understanding of reality as we know it. Secondly, string theory could provide a quantum theory of gravity, unifying all of physics under a single theoretical framework. This would mean that the 4 fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, could all be explained as different manifestations of one thing: tiny, vibrating strings of energy. This unification has been a long-standing goal in physics and, if achieved, could revolutionize our understanding of the cosmos. But like any theory, string theory is not without its critics. One of the major criticisms is the lack of experimental evidence. Despite its mathematical elegance, we've yet to observe these tiny strings or any direct evidence of extra dimensions. Furthermore, the mathematics of string theory is incredibly complex, which some argue makes it more of a mathematical exercise than a physical theory. Moreover, string theory requires a staggering number of different solutions, each corresponding to a different possible universe. This has led to the so-called landscape problem, where it becomes almost impossible to make specific predictions about our own universe. Despite these challenges, string theory continues to be a vibrant field of research, pushing the boundaries of our understanding of the universe. As we continue to probe the mysteries of the cosmos, who knows what fascinating discoveries await us in the realm of the very small and the incredibly vast. So, to wrap up, let's summarize what we've learned about string theory. At its core, string theory proposes that the universe isn't made up of point-like particles, but rather one-dimensional strings. These strings are tiny, tinier than anything we can currently measure, and they vibrate at different frequencies. Just like a guitar string can vibrate to produce different musical notes, these strings vibrate to create different particles. Electrons, quarks, photons, all the building blocks of our universe are just different notes in a cosmic symphony. Beyond this, string theory boldly suggests the existence of extra dimensions. While we're used to 3 dimensions of space and 1 of time, string theory necessitates up to 10. These additional dimensions might be compacted so tightly that they're almost impossible to detect, or they could be vast and infinite, giving rise to other universes entirely. It's a concept that challenges our very perception of reality. As for the implications of string theory, they're profound and far-reaching. If proven true, it could reconcile general relativity and quantum mechanics, 2 of the most fundamental yet incompatible theories in physics. It could provide a unified framework for understanding all of nature's forces. It could even offer insights into the very birth of our universe. Despite its promise, string theory remains a theory in progress. It's a tool for probing the deepest questions about our universe, yet it's still under development, and much of it remains untested. The road to a full understanding of string theory is long and winding, filled with challenges and uncertainties. But that's what makes it exciting. Every new discovery, every step forward brings us closer to potentially revolutionizing our understanding of the universe. The ongoing research and future directions in string theory hold a promise of uncovering new layers of reality, of unveiling the fundamental nature of everything that exists. As we continue to explore the mysteries of the universe, who knows what other fascinating theories await us? After all, in the quest for knowledge, the journey is just as important as the destination.